An active circuit shown here with 3 op-amps. We assume op-amps are ideal. Op-amps are properly biased. By biased, I mean we are making the assumption that positive voltage, VDD, and the negative voltage, let's say uh, minus VDD or minus VEE, is properly connected so that the op-amps are properly biased and they are not saturated. And at the same time, you can see that all these 3 op-amps are in negative feedback. So with that assumption, let's assume um, all op-amps are properly biased, ideal, and not saturated. So they are in linear mode of operation. Therefore, we can use the virtual short. Therefore, virtual short holds. And by that, I mean the voltage at the input of the positive terminal should be equal to voltage at the input of negative terminal. So V positive should be equal to V negative. That's what we mean by virtual short for the ideal op-amp in negative feedback when it's not saturated. Given that the positive input terminal is at 0, therefore negative input terminal is at 0 as well. This is a simple uh, scenario in which V1 just with a gain of negative 50 over 25 will get to Vx. So basically a current that is flowing this way because input impedance of the op-amp, of ideal op-amp, when it is not saturated in this proper bias scenario, has input impedance of infinity, therefore no current can flow through the input terminal, and the whole current should continue flowing, in this case only through 50K, and therefore, just as a reminder, it will be V1 minus 0, which is this voltage. As I said, its V negative terminal should be equal to V positive equal to 0. So V1 minus 0 divided by 250, 25K, that's the resistor, so this is the current, and should be equal to 0 minus Vx, voltage at node X, divided by 50K, the resistor between the two nodes, as you can see. So if you reshuffle things around here, obviously what we already know should be obtained. Vx as over V1 should be equal to negative 50K divided by 25K. Negative 50K divided by 25K. So as a result, I just wanted to conclude that as we expected, let me just write it here. So as we expected, this will become equal to negative 2. All right, so let's remember this. That is the relationship between Vx and V1. So Vx is equal to negative 2V1. Okay. Now the same thing can be applied to node Y. For the same reason, the current flowing this way from V2 should flow completely through the 50K as well. And we can just say as simple as this, that Vy over V2 as well should be equal to negative 50K. So negative 50K divided by 25K. Again, equal to negative 2. So let's have that in mind as well. Okay. So as a rewrite, you can also say it this way, right? Vy equal to negative 2V2. Okay, now the last thing we have is a V3. So in this scenario, V3 is just getting connected to this node, and we are using superposition. So when we are computing because we have 3 independent input voltages, so when we say V1 like this, what we mean is effectively there is an independent voltage source connected to ground, and the value of it is V1. The same thing about V2. When we say we have V2 like this, it means there is an independent voltage source with a value V2 and then connected to ground. The same thing about V3. There is this independent voltage source and connected to ground. Okay, so with that in mind, when we are trying to find the impact of the summation of V1, V2, V3 via this active circuit, we use superposition. It means that when we are dealing with V1, we assume V2 is 0, so it means input for number 2 terminal is shorted. V3 0, this is also shorted, so nothing is happening there. And of course, since the op-amp is in properly biased, not saturated in negative feedback, therefore virtual short holds. So for this op-amp as well, V plus is equal to V negative terminal equal to 0 because it is 0. So since the voltage at this node, at node Z, is forced to 0, therefore it doesn't matter what's the situation with V2 and V3 is for the V1 and what's the situation for V3 is when V2 and V1 is V2 is shorted. So when we want to compute the gain from V3 to V out, as a part of superposition, we assume V1 is 0, V2 is 0. When we make that assumption, it means as a result, Vx is 0, Vy is 0, and they are not contributing any current. So the only thing that contributes a current would be a current coming from V3, and this node is 0. So that current will pass through and will get to 20K. As I said, in that mode, Vx is 0, Vy is 0, so no current can flow the other way. So that's the only possible route for the current coming from V3 when we are assuming V1 and V2 are shorted. If that is the case, then we simply have a similar situation. So what we are saying, just writing one KCL at node Z. So KCL at node Z. If you write it, it will be V3 minus VZ, V3 minus VZ is 0 volt because of virtual short, and the only resistor here is 40K. So divide by 40K is equal to VZ, which is 0, minus V out, divide by 200K. So what we get from this outcome is, as we expected to see V out directly as a function of V3 is equal to, so let me get rid of this sign, it's unnecessary. Okay, so V out over V3 is equal to negative 200K divided by 40K, which means negative 5. So that's the gain we have for V3 contribution to V out. Now we can combine all these things and remember that the same thing applies. For the same reason, we can see that from X to out, there is a gain of 200 over 20K. So just to remind you that V out over Vx is also equal to negative 200K over 20K, which means negative 10. And you can say the same thing about V out as a function of Vy. So V out as a function of Vy, so V out over Vy is equal to the gain from Y to V out is 200 over 25. Negative, which will be minus 8, negative 8. Okay, so now we have all the components. From V1 to Vx, we have the gain. So what I can write is something like this. Using superposition, therefore I can say V out is equal to, from Vx from V1 to Vx, I can write Vx is equal to negative 2 times V1. So from V1 to Vx, I get a gain of negative 2. From Vx, from the x to out, I get a gain of -10. So effectively, it's a gain of -10 times gain of -2 times V1. Okay, from the same argument, from V2, the node 2, input node 2 to node Y, we can see there is a gain of -2 as well. Vy equal to -2 V2. Now from node Y, so from 2 to Y, there is a gain of -2. From Y to out, there is a gain of -8. So we have a negative gate times -2 times V2. And finally, from V3 to V out, we just computed that V out is -5 times V3. So it's just -5 times V3. So as one final outcome, summarizing what we learned, I can just say V out is equal to 20 times V1 plus 16 times V2 minus 5 times V3. So no wonder, as we expected, this simple active circuit with 3 ideal op-amp is realizing a linear combiner or linear combination of 3 input voltages, as you can see with with these coefficients of 20 plus 16 and minus 5. I hope that this video is helpful.